overview is for lesson 1 of the unit 8, which is square root functions. This unit actually has 2 parts to it. There's a calculator part and a non-calculator part. And this lesson is no calculator, and then lesson 2 will be calculator lab. So this stuff is very similar to the unit that we did on transformations of quadratics, which was back in unit 5 or 6, I think. Let's see. It would be unit 5, was vertex form and transformation. So the left, right, up, down, reflecting, stretching. We'll do all of those with square root functions today. All right, so we're not using our calculator for this lesson, so make sure you really understand those transformations. We're going to look at the graph here. So it says consider 2 functions, square root of x and g of x, which is the square root of x plus 3 minus 2. We already graphed square root of x. That's the guy that's right here on the paper. That's f of x. And that is what we call the parent function for the square roots. There are dots darkened on your paper. It's a little hard to see here on the screen, so I'm darkening them in. But those are the key points. This is essentially a sideways parabola. Remember when we did a parabola, we went out 1, up 1, out 2, up 4? Well, it's the same pattern, but we're off to the side. We're flipped to the side. So it says use your knowledge of the transformation rules to graph g of x, which is, I'm going to use purple here, this function. So remember, when there was a plus sign underneath the radical or inside the parentheses, that meant that your graph was going to the left. So our graph here is going to be going left 3, and the minus 2 on the outside means our graph goes down 2. So if I take each of these points, I'll start at the origin here. I'm going to go left 3, down 2, and plot them. So you can do that to each and every point on this function. And once you connect them, you should have a graph with the same shape, left and down. Now what we're looking at here next is we also not just want to make a graph, but we want to talk about the domain and the range. This has been following you the whole course. All right, domain and range deals with the x's and the y's of the function. Let's talk about f of x, which is the graph in pink. I'll use the same color. So we're going to state the domain and range using set builder notation by just looking at the picture, and then I'll remind you how to do, actually, let's just look at the picture now. We'll deal with algebraically on the back. I don't want to worry too much about that right now. I just want to review domain and range. So domain is the x's. So if I'm looking at my pink graph here, the farthest to the left x that it's at is 0. And then we go to the right. It goes on forever. So my domain starts at 0. It's included. Since it goes to the right forever, my graph goes to infinity. Now the range is bottom to top. Now on the bottom here, we're at 0 again. And my graph goes up forever, which means it goes to infinity. When I look at my transformed graph, g of x, the purple one, same thing with domain. I go all the way to the left. Here my leftmost x is at -3. And I still go to infinity. I'm going right forever. The range is the bottom. Well, the lowest y value here was at -2. And this graph went up to infinity. So that would be the domain and range for those first 2 graphs. And again, we'll deal with the algebraically stuff on the next page. Let's look at more of the graphs here. Example number 2, which of the following, it's multiple choice, would represent the graph shown? Well, if you need to graph the parent function to see, you can. The parent function looks like this. I went out 1, up 1, out 4, up 2. The next one will be out 9, up 3. Now, this graph looks like it's flipped upside down. It looks like it has been flipped over the x-axis. So this graph has been reflected over the x-axis. And then it just looks like it went to the left 4 units. It didn't look like it went up or down. So remember, reflecting over the x-axis, that first transformation, is a negative out in front of the entire equation. So that means I can eliminate C. The rest of these at least all have a negative in front. If I go to the left, that means that we're going to have a plus sign, the opposite of what you think, inside the radical. So B, the plus is outside, that means you went up. D is moving to the right, so A has to be our correct answer. All right, flip the page over. Let's talk a little bit more about domain. Now, we did this back at the beginning of the course, I believe. Determine the domain for each of the following functions. Remember, domain is x value. So let's talk a little bit about square roots before we jump into the algebraic finding of domain. When you have a square root, right, I could take the square root of any positive number I want. So I am allowed to have positive numbers under the radical. I can even take the square root of 0. That's equal to 0. So I can have 0 under a radical. I can have positives, I can have 0. But then, when I have the square root of a negative, we say that that's not a real number. That's not allowed. So I cannot have negative numbers. So I can have positives, I can have 0, I can't have negatives. So what this turns out to be is I can have all numbers equal to 0, and can have all numbers that are greater than 0. So mathematically, we combine those symbols to say we want all numbers greater than or equal to 0. Those numbers are allowed to be underneath the radical. So what that allows us to do is say, okay, this whole thing under the radical, this x plus 2, that's called the radicand. That's called what we call the thing under the radical. That radicand, the whole value, has to be greater than or equal to 0, because it can be equal to 0 when I find a value for x. It could be greater than 0, but it's not allowed to be negative. So I'm restricting what I let that radicand to be equal to by setting it greater than or equal to 0. So now when I find the x value, this is going to give me the domain. Remember, domain are the x values. What x values am I allowed to put in to this radical that makes it so that the thing under the radical isn't negative? So I'm going to solve the equation. When I subtract 2, I get x is greater than or equal to negative 2. That will be your domain. I'm allowed to take any x value equal to negative 2 or bigger than negative 2 and put it into the equation. So let me show you what that means. If I take a number equal to negative 2 and put it under the radical, I would have y equals negative 2 plus 2, which is radical 0, which equals 0. That's allowed. We're allowed to have a square root of 0. If I took a number bigger than negative 2, let's try 5. If I made x equals 5, I would have y equals the square root of 5 plus 2, which is the square root of 7. I'm allowed to have the square root of 7. Now, if I took a number less than negative 2, like negative 5, I would have y equals the square root of negative 5 plus 2, which is negative 3. And I'm not allowed to have a negative under a radical. That's why those numbers are not in our domain. Our domain is just the numbers greater than or equal to negative 2. I hope that makes a little bit of sense. Let's see another one. Domain and range is kind of a tricky concept. The next one here, again, I take what's under the radical. I take my radicand and I set it greater than or equal to 0. I want to solve that equation so that I get x values that make the highlighted part 0 or bigger. So I add 2. I get 3x is greater than or equal to 2, and then divide by 3. So here my domain is all the x's greater than or equal to 2/3. Right, and that would be your answer. I'll spend a little bit more time on C. I'll go back through like I did in the first one, testing numbers. 8 minus 2x. So I take my radical, or my radicand, set it greater than or equal to 0. I'm going to solve for x. I'm going to subtract 8. Get negative 2x is greater than or equal to negative 8. And then divide by negative 2. And you should have warning signs going off in your head right now. I divided by a negative. That means you have to flip the inequality sign right here. So when I have x by itself, that sign flips over to look like this. X is less than or equal to 4. That is the value of x, that is our domain. Now again, let's talk like the first problem, what that means. If I took x equal to 4, right, I have less than or equal. So if I took x is equal to 4, and I put it into the radical, I would have the square root of 8 minus 2 times 4, which is 8 minus 8, which is the square root of 0. That's good. We're allowed to have 0 under the radical. So that's why x is allowed to equal 4. If I take x is less than 4, so let's even just try 3. That's a number less than 4. I would have y equals the square root of 8 minus 2 times 3, which is 8 minus 6, which is the square root of 2. I'm allowed to have the square root of 2. It's irrational, but it's okay. If I took x is something greater than 4, let's just try 5. Y equals the square root of 8 minus 2 times 5. Well, that's 8 minus 10, which is the square root of negative 2. That's not a good thing. That's why we can't have numbers bigger than 4, because I'm going to get a negative under the radical. Okay? So as long as you can set up the equation by taking the radicand, what's under the radical, and setting it greater than or equal to 0, and solve the inequality, you can find the domain. Now let's get back to transformations. Let's get back to graphing. I have the function. We did this multi-step graphing back in Unit 5. G of x equals 3 times x, square root of x minus 4. I graphed the parent function for you. We're going to start by stating all the transformations and then graphing them. Then we'll find the domain and range. So this 3 that's out in front, that means that your graph underwent a vertical stretch by a factor of 3. Remember, the number in front, when it's greater than 1, is a vertical stretch. The minus 4 underneath the radical means that my graph went to the right 4 units. So you're going to take each point, and you can pause the video and slow it down here. I go a little faster because I have a lot of practice with this. So you're going to take each point from this graph, and you're going to stretch them and move them right. So when I'm at 0, remember when I vertically stretch something, I multiply the y value by 3. So I'm just going to label the y values here. 0, 1, 2, 3. Those are the y values of the point. 0 times 3 is 0, so that point stays right here. At 1, 1, the y value is 1. 1 times 3 is 3, so my point is 1, 3. 2 times 3 is 6, so my point's going to be at 4, 6. 3 times 3 is 9, so I'm at 9, 9. That's my graph that is vertically stretched by 3. Now all I have to do is take those points, each of them, and move them right 4. So 1, 3 will now be at 4, 3, and 4, 6 is at 8, 6. Right, the last point won't fit. So there's your final graph. Now let's talk domain and range. Domain is the farthest to the left, x, which is right here at 4. My graph goes from 4, including, because it's a closed dot, out to the right forever because of the arrow, so that means we go to infinity. The range starts at the bottom, that's at y value of 0. And again, I have an arrow going up forever towards infinity. Next one. All right, we start in the front. We have a negative out here. That negative means that my graph reflects over the x-axis. The 1/2, whoops, dropped the pen. The 1/2 means that I have a vertical compression by 1/2. And then the plus 6 outside the radical means that you went down 6 units. So when I'm reflecting a graph, I'm going to take each of these values over the x-axis, we're just going to flip the points equally underneath the axis. The point at 0 stays put. Now, since this point's at 1, positive 1, it's now going to be a 1, negative 1 when I flip over the x-axis. And you need to make sure you know the difference between the x and the y-axis here. The x-axis is the horizontal one. All right, I'm at 4, 2. So when I flip over the axis, I'll be at 4, negative 2, and then 9, negative 3. There's my reflected graph. Now I'm going to vertically compress by 1/2 here. I'm going to try maybe to make this a little bit thinner to make the line. Okay, so compress by 1/2. That means that you're taking the y values, and I'm going to darken them in here. Take the y values, make them half as big. So my y values are at 0, negative 1, negative 2, negative 3. Half of 0 is 0. That stays put. Half of negative 1 is negative 1/2. Squeeze that in. Half of negative 2 is negative 1. And half of negative 3 is negative 1.5. So it gets really bunched up there, but try to squeeze it in. Finally, I'm going to take all those points and just move them down 6. So my first point is 0, negative 6, 1, negative 6.5, 4, negative 7, 9, negative 7.5. And there's my graph. All right, domain and range. Leftmost x value is at 0. So I'm going from 0 towards infinity. Now I want you to be careful in the range. When I reflect over the x-axis, I start on the bottom. The bottom actually has an arrow, which is going from negative infinity up to, it does not get higher than the y value of negative 6. So this time my range is negative infinity up to 6 at its highest point. All right, next one. 2 times the square root of negative x minus 2. So the 2 in front represents a vertical stretch by 2. The negative under the radical is a reflection over the y-axis. Remember, the negative underneath is the y-axis, and then the minus 2 on the outside means that you went down 2. So vertical stretch by 2. We've done a couple vertical stretches and compressions now. Remember, you're changing the y values. So I'm writing the y values on the parent function. When I vertically stretch something from 0, that first point doesn't change. 1, 1, I'm vertically stretched by 2. So the y of 1 gets multiplied by 2 to be 1, 2. 4, 2 becomes 4, 4. And then 9, 6. Multiplying the y's. Now when I reflect this over the y-axis, you still need to know what the y-axis is. That's the up and down, vertical one. So you're going to take all the points and flip them over that blue axis there. The origin stays the same. This point at 1, 2 goes to negative 1, 2. It's going to go the opposite way. Negative 4, 4, and negative 9, 6. So now my graph is flipped the other direction. And finally, you just take each of those points and move them down 2. You need a little bit more time. Go ahead and take it. Domain and range. Domain is the left and right. I have an arrow on the left, which means my graph goes from negative infinity until the right value of 0. That's including the point of 0. The range, I start at the bottom. The bottom this time has a negative 2 as its lowest point, and it goes up to infinity because of the arrow. All right, last little bit here. I'm just going to talk about writing the equations given the transformations that are stated. So we're going to transform y equals square root of x. When I reflect over the x-axis, remember that means you have a negative in front of the radical. And then down 7 happens outside the radical as minus So that's your equation, negative square root of x minus 7. Vertical stretch by 3. That also happens outside the radical, right? I have a radical here. The vertical stretch goes outside. Left goes inside the radical. And you'd think left is negative, but it's opposite. So it's x plus 5. That means to the left. And up 2 is plus 2 on the outside. All right, finally, vertical compression. That happens outside the radical. If I compress by 3/4, I put that in front. Reflecting over the y-axis is when you have a negative in front of the x under the radical. All right, there is 2 sets of practice for this lesson. Go ahead and try those and watch the videos and check the key if you need some help.